Hello everyone. Once again, welcome to Engineer Dove's tutorials. One of the important topics in fluid mechanics is the buoyancy, no? Okay, so this is chapter 4. So what is buoyancy? So buoyancy starts with Archimedes principle, no? That any body immersed in a fluid is acted by a unbalanced force called the buoyant force. Okay, so what is buoyant force? So buoyant force is defined to be a net force, no? Net force from a fluid pressure acting on the surface of an object, no? That is either completely or partially submerged in a fluid at rest. Since fluid mechanics is dealing with fluid at rest, so, di ba? The buoyant force must have zero horizontal components. Okay? Zero horizontal component. And a vertical component equal to the weight displaced by the physical object. Okay? As we can see, no? As we can see in the figure, we have two objects, no? The first, this figure is an object is partially submerged. This, no? This is the volume of object submerged volume, and the second figure is completely the object is completely submerged. Okay, going back to the definition of the buoyant force, net force. Let's say let's consider this figure, no, this one, because this object is submerged in fluid, so meaning to say this object is submerged, is subject to pressure, no? Say, since it is stated that the horizontal component of the fluid pressure acting on this object is zero, so we will just focus to the vertical component of the fluid pressure, which is the buoyant force. Say this is the pressure, no, vertical fluid pressure. Okay, so we have also here, okay, okay, let's say the total pressure or the total force due to pressure at this surface, say we will call this one as F1, and at this surface this is F2. Okay, and it is stated that the buoyant force is defined as the net force. So meaning this buoyant force, this is the difference between F2 and F1, and it is given by the equation BF is equal to gamma of fluid times the volume displaced. Okay. For homogeneous body floating on a homogeneous liquid, so we have this equation: the volume displaced is equal to the unit weight of body over the unit weight of liquid or fluid times the volume of body. Okay, to simplify this one, since we know that gamma is equal to density times gravitational acceleration, So this equation can be simplified to this equation, as well as, since we know that density is equal to S, specific gravity, times the density of, no, or say the gamma is equal to specific gravity times the gamma of water. So this equation can be simplified to this one. So just familiarize the equations, no? For vertical position, no? For vertical position, let's say this object, the cross-sectional area of this object is constant. This equation, this one, can be simplified to this one. Let's say volume displaced of the object. So this one, let's say the volume displaced, considering this figure, our volume displaced is equal to the area times the draft d, this distance, no? Okay, this distance d, and also the volume of the body is equal to area times height. Okay, if we substitute this into this equation, we will come up with this equation. Okay, if the object is in horizontal position, this equation will apply. Okay, so example number 1. An ice having a specific gravity of 0.96 is floating on salt water. So salt water, our fluid in this problem, or in this example, is a salt water. If the volume of ice above the sea water surface, or this one, this surface is 100 cubic meters, what is the total volume of the iceberg? Since the specific gravity of the ice is less than the specific gravity of salt water, by the way, the specific gravity of salt water, no, is equal to 1.03, no? So we will expect that some of the volume of the object will be exposed. Okay, so because it stated in the problem that 100 cubic meters of volume of the object is above the water surface, no? So we can create an equation, no, that the volume of ice is equals to the volume displaced plus. So this is the total volume of ice, no. So is equal to the volume displaced plus 100 cubic meters, or the volume exposed, no. Since our goal is to determine the total volume, no, this one, total volume of ice. Okay, from this equation, uh, from this equation, okay, so this one, no, the volume displaced is equals to the specific gravity of ice over the specific gravity of liquid, which is salt water, times the total volume of ice. And if we substitute this equation, we substitute to this, we will come up with this equation with a variable volume of, or the total volume of ice, and finally we get the total volume of ice. Okay,